This is a May, June 2022, variant 42 question. A part 1, carry 2 marks. You have to define gravitational potential at the point. The gravitational potential at the point is defined as the work done per unit mass. You must mention unit mass. In moving the point mass, which is a unit mass, from infinity to the point. Part 2, starting from the equation for the gravitational potential due to a point mass, show that the gravitational potential energy EP of a point mass M at a distance r from another point mass capital M is given by this equation, where G is a gravitational constant. In order to answer this question, you need to know a few things. Number 1, you need to know why gravitational potential and gravitational potential energy have negative values. Then number 2, you need to know the relationship between gravitational potential and gravitational potential energy. The relationship is given by this equation here. To simplify our discussion, we will consider two masses represented by A and B. A has a mass of small m kilogram. B has a mass of big M kilogram. And then the point is represented by the alphabet P. We will then consider the gravitational potential and gravitational potential energy of B at P, at this point P, and then the distance between the point P and the center of B is R. For gravitational potential, A has a mass of 1 kilogram. This means that the gravitational potential at the point represented by P due to B is the work done to move 1 kilogram mass, unit mass, from infinity to P. For gravitational potential energy, A is a mass of m kilogram. This means that the gravitational potential at P, at the point P, due to P, is the work done to move m kilogram from infinity to the point P. The gravitational potential at infinity is 0 joule per kilogram. And the gravitational potential energy at infinity is 0 joule. This is the EP. This is the gravitational potential. These two values must be memorized by you. You must know that the gravitational potential and the gravitational potential energy have a value of 0 at infinity. Then, work is done by A, when you move from infinity to the point P. Because gravitational force between A and B is always attractive. No effort is needed to move A from infinity to P, because B always attracts A. B always attracts A. Work done by A is therefore negative. In other words, A will lose potential energy, or A will lose energy. This explains why the gravitational potential and the gravitational potential energy at the point P have negative values. The gravitational potential at the point P is given by this formula. The minus sign shows that the gravitational potential at P is negative. Number 2, the relationship between gravitational potential energy and gravitational potential given by this equation. So your EP equals to your gravitational potential times M. But we know that gravitational potential is minus Gm over R, minus Gm over R times M. That's why you get minus G big M small m over R, which is proven here. In part B, figure 1.1 shows the path of a comet of mass 2.2 times 10 power 14 kg as it passes around a star of mass 1.99 times 10 power 30 kilogram. This is a path taken by the comet. At X, the comet is 8.44 times 10 minus times 10 by 11 meter from the center of the star and is moving at the speed of 34.1 kilogram per second, which is given in this diagram. At Y, the comet passes the point of closest approach to the star. The star this is a star. At this point, the comet is a distance of 6.38 times 10 power 10 meter from the center of the star. Both the comet and the star can be considered as point mass at their centers. Calculate the magnitude of the change in gravitational potential energy, delta EP, of the comet as it moves from X to Y. When the comet moves from X to Y, you can see that the distance between the comet and the star is decreasing. So the situation is like some object falling towards the surface of Earth, so that the height decreases. That means the comet will lose gravitational potential energy. The gravitational potential energy at X is equals to minus Gm, the star. Then E refers to the the C refers to the comet divided by the distance of the comet at X from the center of the star, which is 8.44 times 10 by 11. And then this is the potential energy of the comet at Y. To calculate the change in potential and gravitational potential energy, we calculate the gravitational potential energy at Y minus the gravitational potential energy at X, which will give you 4.23 times 10 to the power 23 joule. Then in part 2, state with the reason whether the change in gravitational potential energy in B part 1 is an increase or decrease. The change in gravitational potential energy decreases because gravitational force is always attractive and work is done by the gravitational force. You can also see that there's a negative sign here. This negative sign shows that the gravitational potential energy decreases. Then use your answer in B part 1 to determine the speed in kilogram per second of the comet at point Y. So when the comet moves from X to Y, it loses gravitational potential energy, but it gains an equal quantity of kinetic energy. The formula for kinetic energy is half mv squared. The loss in gravitational potential energy, which is 4.23 times 10 power 23 joule, is equal to the gain in kinetic energy. The gain in kinetic energy is equal to the kinetic energy at Y minus the kinetic energy at X. That's why your delta EP is equal to half m Vy squared minus Vx squared. Vy represents the velocity at Y and Vx represents the velocity at X. Then after substituting the values into the equation, you get Vy as 70,800 meters per second or 70.8 kilometers per second. So to do this question, we need to know the law of conservation of energy. Then part C, a second comet passes point X with the same speed as comet in B and traveling in the same direction. This comet is gradually losing mass. The mass of this comet when it passes point X is the same as the mass of the comet in B. Suggest with the reason how the path of the second comet compares with the path shown in figure 1.1. The answer is both the gravitational potential energy and kinetic energy equation include m. Therefore, the path is not changed because the m will cancel off. This is the equation for gravitational potential energy. And this is the equation for kinetic energy. You can see that the small m will cancel off. So in other words, the path does not depend on the mass of the comet. So this is a summary of the facts that you must know to solve this question. Number 1, you must be able to define gravitational potential at a point. Number 2, you must be able to state the formula for gravitational potential. Number 3, you need to know the relationship between gravitational potential and gravitational potential energy, and the formula relating the two. Number 4, understand that gravitational potential and gravitational potential energy have negative values. Number 5, know the formula to calculate the kinetic energy of a comet moving around a star. Understand that the gravitational potential energy of a comet decreases as it moves closer to the star. Then number 7, use the principle of conservation of energy to state that the decrease in gravitational potential energy is equal to increase in kinetic energy. And these are the important facts that you need to know to solve this examination question.